It's podcast time. Oh my goodness. Is it Wednesday? Wait a minute. Was there a reason I was playing that song at the start? I don't know. Looks like you're going to have to watch and find out. I was having a little fun with this one because why not? I mean, if you're going to do this, enjoy yourself. My name is Eric Wright. I'm the host of the DiscoPosse. Why am I holding this guitar? I'm the host of the DiscoPosse podcast, and you are watching my channel featuring amazing conversations with amazing people. And the conversation you're about to enjoy is with Tyler Browder. He's the CEO and co-founder of Kubos. They are doing really, really neat stuff with this mission control software that's cloud-based. So you just nailed everything that I love. Great humans, space, cloud, mission control, thus the Space Oddity reference, in case you didn't figure out what that horrifying rendition of Space Oddity was. Now, Tyler talks about the challenge that they try to solve. I really dig in with him on the approach in building a company and building technology that's very specific and focused. They go into a ton of really interesting areas. We go into the background of their open source roots, where they are today, and also we dig into some really interesting stuff around what he did in his origins with a group called TechMill. This is a fun episode. Tyler was really enjoyable. And if you want to see this and many other great conversations like it, number one, recommend it to a friend. But in the meantime, just do me a favor and click that like button. And if you want to click that subscribe button, hit the little bell icon, and that lets you know when new episodes are coming up. Because they're coming out every week. Plus, we got vlogs, we got other things. All right, let's just get into the good stuff. This is Tyler Browder of Kubos on the DiscoPosse podcast.
My name is Tyler Browder. I'm the CEO of Kubos. We build mission control software for spacecraft operations. And you are listening to DiscoPosse Podcast.
Thing of beauty.
That was it.
You nailed it. So this is really cool, Tyler. I want to thank you for, first of all, doing what you do. As a fan of things that leave the earth, I really enjoy. You know, when I saw your name come up, I thought, oh, all right, we're in a cool space, literally. Yeah. So for folks that are new to you, Tyler, do you want to give a quick intro, a bit of a bio? We'll talk about Kubos. We'll talk about what you're doing, what the team's doing. Oh, this is it. And I feel like I should have like acoustic guitar playing Major Tom as we're going through. People will get what that reference is about in a few minutes. There's a lot to cover there. No, so let's start with Kubos. Kubos is a software company, right? We live in a hardware world, though. Space is dominated by hardware, right? People did not get in this space to put little bits and bytes into space. They got in to build, a physical thing and launch it and then communicate with it. But we decided to come at a different angle. And so we built a product called Major Tom, which is a mission control software for spacecraft. So it lives on the ground. It's a cloud application that we use to track our satellites, to understand the data coming down from the satellites, and then tell the satellites what to do, right? So it's the primary tool, once the satellite's in orbit, that people use to communicate and understand their satellite, right? So it's a pretty critical, not to beat on this, mission critical piece of software that it's a window that customers use to understand their spacecraft. So it's a lot of fun. We don't actually send anything to space because we're on the ground side, right? We're listening back from it, but we're pretty close. My background, though, you asked about is, I got quite a non-traditional background into aerospace. So, most aerospace professionals get into the business because they dream to being an astronaut or something along those lines, and it was a passion from early on. No one stumbled into aerospace by accident, except for me.
And so my background is primarily like in just entrepreneurship, business development. I grew up in an entrepreneur family. And so done healthcare, I've done music industry, I've done property rental companies, and I got an opportunity. I became friends with a guy who was a software engineer who had worked in space, and he was looking to start a new company, and he needed someone to handle kind of the business aspects of the new venture, and he would handle the technology. And yeah, that's how. And I said yes. I didn't know what a satellite was. I was never like a big space kid growing up. I didn't dream of being an astronaut. I dreamed of being a rock star. And so yeah, I was fortunate enough to stumble into the industry.
One would say that these days they're one and the same. You see the way they do the walkouts.
Oh yeah.
It's not unlike a WWE. You just expect someone to be walking with a flag and people cheering, and it's amazing to think of just the amounts that's going on with both commercial and public sector stuff that's happening in space, and then the private sector. There's an untold number of things that are going on in this area of development that are they used to be more hidden, but now, I mean, let's just say it, right? Elon Musk made it kind of cool to really sort of push the envelope and make it a more of a spectacle to observe and enjoy, that we are doing this incredible development in the world of space. And then we start to see what people are doing with like the CubeSat side of the world and all these small commercial stuff, and almost hidden behind that too that's amazing. But what we're doing with the technology that we're putting there is even more amazing, right? So this is why mission control, mission critical is big, because it's not just about getting it up there. It's about, we're building systems on this technology that require us to now treat it like this is big. I mean, it is really amazing.
Yeah, there's a lot of different ways you could go with that. From the industry standpoint, historically space has been a government playground, right? Like only governments had the resources and the appetite to go after it. And that's all obviously changed, right? And that's good, but that's created quite this like change in cultures in the industry. Government run programs were very secretive. It was all about national security, and so there was this culture of not talking publicly about what we're doing, except for a very select few propaganda type things or big name things. Elon has definitely done he's done more than his share to move the industry into the public light. And so we're seeing this really interesting, when you get down into it and talk with people, there's still this culture of keeping things quiet, not talking about what we're doing. And there's other people who are trying to follow in line of what Elon done and talk about their projects and be very vocal. And so we've seen that from a lot of different really interesting angles. But on the technology side, when it was a government program, they were everything was really special, right? Everything was custom built to achieve one objective, and up and down the stack, everything from the spacecraft all the way down to delivery of the data, including mission control. It was a very custom program that was designed just for the operation of that particular spacecraft. It could not be transferred. What CubeSats have done is give us some standardization. And allowed us to build more in bulk, right? And build more spacecraft than we ever thought. Instead of really big spacecraft, we got lots of little ones. And so, the way we really like to position our product is that we're an infrastructure play, right? Every piece of machinery in space has the same core components. They all need power, right? Battery, solar panels. They all need a computer of some sort to control, and they all need a radio. They need to be able to communicate back to Earth, and then they need some way to do whatever it is they're wanting to do, right? And that's where all the custom stuff comes out. If it's a camera to get pictures, or if it's some sort of sensor measuring some sort of data in the atmosphere or whatever. And so what we focus on is the generic parts. So the radio, the computer, the battery power, the what they call the telemetry of the spacecraft bus, as opposed to the actual payload. We don't have our platform does not support payload data, so that image processing. We don't do that. That's what our customers want to do. That's their secret sauce, right? That's why they built the spacecraft to begin with. But we handle the satellite operations itself, the health and status, where it is, where it's going, communicating to the payload to take a picture over Cairo next Tuesday, whatever the command is. And so we facilitate that whole communication chain to the spacecraft.
And you're doing it in, speaking of public, in the open. The fact that you've actually open sourced a lot of the work, there's a lot of interesting things. I'd love to get your take on what stuff is very sort of community world driven, and how much is interior special sauce even in, you know, what Major Tom and such is delivering.
Yeah, so it's a great question. So I think actually to answer that question, I had to back up a little bit. So when we started Kubos, we actually started with a different focus. We were focused on flight software, basically creating the operating system of the actual spacecraft. And that product was called Kubos, and it is open source, and it was very much modeled after the Android operating system. And so we would have a Linux kernel, we have middleware that we built, and then a bunch of APIs so that customers could build their own custom applications on the spacecraft to do whatever they're trying to do. It was hardware agnostic. We could really shift around. We went to bus providers or satellite manufacturers and got them to distribute it. And we built that all in the open. We had an open source community. We had the code was all open source. And we did that for a couple of reasons. One, we believed in that. That was kind of the ethos of where my partner, who was a software engineer, came from. He came from, you know, Mozilla and Red Hat and big open source commercial companies. And so that was part of who he was as a person. But also the truth is, from an export control standpoint, by making it open source, we got around a lot of the export requirements of the software, and we could distribute it without having to verify who was using it, or you know, having to keep tight controls around that. And that was, as a small company, that was a really heavy burden to do the export control. And so open sourcing gave us a way around that. Major Tom, we shifted to that last year heavily. And Major Tom is actually not open source. It is just a web application that we control the source code. And there was a couple of different reasons for that and why we've done all that, and we can get into that if you like. But you know, just for clarification, Major Tom actually is not open source, and our previous product, Kubos, it still exists. It's still there, being used by people today.
Yeah, and that's what I wanted to sort of show, that interesting split of the line. I do a ton of work in the open source communities, in a lot of different ones. And I'm a huge proponent for open source and open communities. But I also recognize the challenge in running a business and also, I mean, commercializing on open source. There's a lot of real challenge around, you have to at some point add opinion into software. You have to have an opinionated approach, and it's really hard to do in a purely 100% open community. And there's a lot of great proponents for, well, they call it COSS, right? Commercial open source. And then open core is another one. It's hilarious because you've got these little, like, you know, occupy open source, you know, occupy open core. Like, there really are like hardened, you know, really strong-minded leaders in these specific types of communities. And they're all sort of arguing over who's more open, who's more DevOpsy. Like, there's all of these like things. And in the end, while that's going on, we're trying to run a business to employ people to get commercially viable software out there that can then, you know, power other companies and deliver this. This is why, you know, inside Major Tom, there's probably open tools amongst it, but nothing wrong with, in my mind, the front end needs to be purely opinionated, pragmatically built, and delivering to solve specific problems.
Yeah, I mean, I completely agree with you. Yeah, sure. Inside of Major Tom, we do have open source elements. I'll be honest, I don't know exactly all of them, so I won't name them, but we do use them, right? And I think most companies, software companies, use open source at some level, right?
Everybody thought they didn't until there was Heartbleed. That was like one of the most hilarious things. We're like, that'll teach you open source people to use open source stuff, and this like Heartbleed, and then all of a sudden, like 12 hours later, Cisco, Microsoft, VMware, like every major company was like, you need to patch your stuff. And they're like, wait, why? I thought we were using commercial software. We're like, well, guess what? It's built on open source software.
Yeah, right. Yeah, no, exactly. Well, so, the problem with, I completely agree with you that we still have to make viable businesses that employees and that generates revenue so that we can, hire people and have economy and all these things, right? But, the problem we had with open source in our industry is we were selling support contracts. So that was our main business model: is you would use our software and we would sell you support, and that works really great for a Red Hat. But that really is a challenge for us. So we were going after companies that were building large constellations. So they wanted to launch a lot of satellites, hundreds of satellites, and then we're going to use our software on all their spacecraft. Awesome. Let's do that. So for the first satellite, they happily paid us for support, and we would support them through it. We build some, we port it to their hardware if we need to. We do some services in there to, generate revenue, and we were successful. We launched some satellites on it, and then they would be ready for their next second, third, fourth spacecraft, and they're going to build them. They're going to try to increase the speed, the scale of it, and bulk up a little bit. And we had taught them everything they needed to know about the software, and they really didn't want to purchase support for anything because they didn't change anything. They weren't intending to change anything or anything significant. And if you imagine, once the spacecraft is in orbit, you have some limited options about what you can do to change that. If you have a bug that is in your spacecraft software, how do you fix it? You could do a software update. So now it's more common. When we started, it wasn't assumed that you were able to do a software update. But it's very risky, right? If you have to do a whole new update to the kernel or to the OS, that's a lot of risk. If you make a mistake, that's it. That the thing's done. It's over. There's no
just hold down the reset button.
That's right. That's right. No plugging it back. No, it's gone. And so it is not something that companies traditionally have been wanting to do unless under the most dire situations. Right now we've gotten better. Our as an industry, we've gotten better at testing and our procedures and our backups on the system, so that there is a failure, we could do it. But especially at the time when we started, that just wasn't the norm. Very few companies had been building and architecting their system with the intent of updating the OS. So there's some limitations, right? There was some risk involved, big consequences. And so anyway, it was a very hard model to get in. And then these sell cycles, there was, we can get into the business side, but anyway, there's a lot going on here. But at any rate, open source is still a part of us. There's still that flight software called Kubos still up on GitHub, and I think the next launch it's on is next month. I mean, it's still being used by people, even though we're not actively developing on it. And so, yeah, I think the next launch that someone's using it is next month, I think.
Nice, yeah.
Yeah, that's great.
And so I guess it really brings the ultimate question, right? Before Major Tom, what did this stack look like? What was the previous solution that needed this to solve a problem?
Yeah, and so there was a couple of different flavors of this, but they all were based around being on a server in a closet there locally at your station. And they were all focused on particularly one spacecraft. They were not going to handle 100 spacecraft. They were really good at 2, 3, 4 maybe spacecraft, but if you were going to do more, they were really not going to be built for that. And they were expensive. You had to have the hardware, and you had to have the at least the skill set to set up the hardware, manage that, and they were real particularly focused on, again, this single use case, this single spacecraft, and so that's really where we, as this industry started to move from big and expensive to lots of little, right? The mission control didn't keep up, right? We couldn't scale the way that the industry was needing us to scale. We couldn't be generic, right? We couldn't be spun up quickly, and we couldn't be updated very well. If it was in the hardware over there in the corner, nobody wanted to touch it. So there was a lack of innovation, right? Satellites, as you deploy more satellites, you continue to tweak and evolve them, right? There's different generations trying to push it, but your mission control stayed flat. So we needed a way to update and upgrade the software to keep up with the demands and the needs of the ever-changing system. So that's really where we came in to fix. So we built it on the cloud to give it that scale, to build it in a redundant, safe way. We built it within mind of operating lots and lots of spacecraft. We've done further than that. So not only just operating a lot of the same kind of spacecraft, we designed it so you can operate a lot of very different types of mission control systems. And then the other thing we've done is we've really gone out and integrated third-party services that you use on the ground. Best example is talk to a satellite. You need a physical ground station somewhere in the earth that will collect the radio signal and also beam up the radio signal. There's services you can purchase. You can basically rent by the minute of these ground stations, and it was always on the operator, our customers, to spend the resources to integrate these systems. And they were done poorly, they were done slowly, they were done costly. And so we've integrated these systems out of the box. So there's just a simple login, and then you're integrated with these systems. So we're lowering barriers, we're going faster, we're developing new features for our customers for these use cases that we can roll out and not have to do a full new reboot of their entire system and lose valuable time on their spacecraft. So that's where we're coming from.
Well, this really becomes the value of centralizing and giving opinionated outcomes to solving a problem, because you can look at 5 customers and then find the Venn diagram of crossover and then start to merge the diagram a bit more. You start to see more commonalities, but they individually are building a standalone system for each part of the operation. It's just such a, there was a point where we all had to do it. So there's always right. The first time someone built a car, you didn't start by building a factory. You started by putting a garage in and then building the bloody car. But eventually someone goes, hey, the guy down the street's building a car and I'm supplying parts to him, and it looks like you guys use the same parts. Okay. Now we got something.
I mean, you're right on. Well, one of the things that we bring is that aggregation of all the different data sets. So we're not looking at actual people's data per se. What we're doing is anonymizing it so that we can better understand spacecraft operations, right? And really where we're trying to apply this is in the communication optimization. So example, you have 100 satellites orbiting the Earth. They're all moving around, right? They orbit every 90 minutes. And you have 10 ground stations across the globe, right? And the connection time between a satellite and a ground station is about 10 minutes, right? And so you got minimum windows, and they're always moving. These are walking orbits, right? If it flies over New York at 2 p.m. at 3:30, it will be 50 miles east of New York, right? The walking. And so what we are building is the optimization on how to communicate. And so we could tell our constellation, I want a picture of New York tomorrow at 1 p.m. The Major Tom will say, you need to send it to this ground station, to this satellite at this time, and get the data back down to optimize the network to get your data, your command up there to tell the satellite what to do, get the data down in an appropriate time. and really optimizing the network. So we're moving away from spacecraft being these pets that we love and are part of our family to cattle, right?
Yeah.
To herds, to big networks, right? We're really more network administrators than we are, satellite operators, and that's the way we're moving the industry to adopt those practices and apply them to the space environment.
Yeah, I'll tell you, and when you get to the numbers, it's pretty incredible if you think about what's up there in the different layers of atmosphere, and it's well, I saw something that it was kind of, I don't know. I'll say it's funny to me because I recognize this is such a, like, get off my lawn, type of old person yelling at the clouds situation.
Sure.
It was like these photographers who are like, it's really bothering me trying to get, night star photography,
Sure.
because there's all these, these darn satellites floating around. You're like, that the internet that you're putting your awful angry tweet on is powered by those very little lights that you're complaining that are crossing your photograph in a time lapse.
Yeah, it's that's a really interesting conversation in the industry that we don't know what to do with yet, right? We're going to launch more satellites. We have to launch more satellites. We have to launch more infrastructure in space, not just satellites, but space stations, and we have to build more habitats, and we have to move out there. And but there's also some consequences to that, right? Not only with photography and the night sky, and that's one, but there's also the risk of a collision, right? These things hitting each other and causing damage, right? There's that risk. There's the risk of, I'm a big fan of the and I just went blank on what it is. The Apple Moon show, from on Apple Plus.
Oh, anyway, For All Mankind.
For All Mankind, yeah, and the militarization of space, right? This is a thing that is not that far away from us, right? And so, and then we got to get into governments, and we got to get into laws and policies and treaties in space that we're not, well equipped to deal with right now in our current geopolitical environment. And so it's really, that's some fascinating things and some really hard decisions that are going to have to be made in the next 10 years to really set up our humanity to expand.
Yeah, the policy side of it is wild. And you think of, because like today we think of geography, like we're so just bound in geography. Even just the fact that, like, as a North American, there's the raw arrogance that everything that most companies do is in English only, and we base it on Eastern time zone. And like, it is just crazy that that's like the standard of belief as we head into just internationally on the earth. We've got a broad set of audiences that are so underrepresented and under-acknowledged. And then, like, we can't even argue over the height over a skyscraper that is considered owned real estate, by that developer. What happens when you go a lot higher? Like, does it belong to the country because it's over North America? Does it belong to the country because it's over, El Salvador? That's my satellite right now. Okay, it's his satellite.
Yeah, right. You're passing. Yeah. It's really hard. I think it's going to be solved. And then you go to like the moon or Mars, and how do we break that up? Should we break it up? Should we not break it up? Right? Asteroids are the same way, and different countries making different laws and not doing it as a planet, as an entire group of people, instead of just individually as our own countries. And so I think it's really interesting. I really do. And how do we solve these problems, and who's going to take leadership in these problems? Who's going to stick their neck out and want to talk about space policy? Because right now it's not on the mainstream, right? It's not being talked about at a high level with people who could do anything about it, right? It's a professor somewhere arguing about it. And so we need to bring that out. We need to talk about that. Anyway, I think it's
most people's exposure to this is just they're like, is Bruce Willis and Ben Affleck available, and can Aerosmith do the soundtrack? Like that's
That's
our
right.
understanding of
That's
space
right.
for the most part.
That's right. That's right. That's right. Well, and America's saving the day, right?
That's right.
That's not how this is going to work. I mean, there are more countries over the last 5 years gotten into space, becoming space faring countries than there were ever, right? And so I mean, you're seeing everybody come play. The countries that had never had a space program now can have a space program,
Yeah.
and it's not just for the United States. It's not just for America. It's a global. Space belongs to all, and so it's really interesting. But there needs to be some structure. There needs to be a rule, because if somebody's doing something with their satellite, how are you going to know that what they're doing, right? Or should you know, right? Do you even have a right to know? But that's a different thing. And that's really fascinating to me. Yeah, we could track where satellites are, but we can't always tell what they're doing. And sometimes by the behavior of the satellite, what it's doing. Since I remember when I first got into the industry, there was a story about in geo. So this is where the big communication satellites live, and they're locked to the spin of the Earth, so they always are focused on a particular spot over the Earth, right? So they're locked in geostationary orbit, and these are very coveted spots. Like these are very big spacecraft. This is big spy stuff, encryption, military, but also other types of communications. And I remember there's this story about this Russian satellite just walking around out there, walking around, getting in between the communication channel, and you can see it. You knew it was a Russian satellite. You knew what they said publicly. We were the same way. What we said publicly, we weren't really saying what our satellite was doing, and it was really interesting. And I think this is going to become more and more happening, whether or not we hear about it or not. But it's going to happen. It's going to continue to happen.
Well, and especially just like it's hard to imagine that if we go back to the days of, before this decade is we commit to getting somebody on the moon, and you're like, that's crazy talk. Now you're like, no one would even question. They're like, why aren't we already there? Like, why are we going back?
Why do we stop going? Right?
Yeah. I think the tough part we also see with the sort of publicity of space, touristing and stuff that's going on the backside of that is an incredible amount of research. Like the work that you're doing, like this enables an incredible amount of real secondary effect stuff that's going on. And going on the moon wasn't about planting the flag. It was about learning about science beyond our Earth. That's enabled an incredible amount of things that is just, we forgot that's what we did as a result of it. Even the sort of the rich man space race that we've got going on right now, the result of those advances will mean that as a government organization, especially at least in the United States, they'll save billions of dollars because of the work that's going on in commercial and private sector work. And we all personally will feel that benefit because it means that things will come that are advanced as a result of this work.
Yeah, it's so we do that in a slightly different way, but it's the same idea, right? We borrow a lot of technologies, best practices, not from the space world, but from the software world, from the general, from what Google and Facebook have developed as standard practices for how to develop large data sets and manage those data sets. And so we are applying those just like that Google had to develop in order to build theirs. We get to use it in space. It's all how this works, right? And so that is, but you're exactly right. These the space race that's happening with Elon and Branson and the other guy Bezos is ultimately going to be, at least to the industry, at least to from the economics, from going to be beneficial, right? They're creating technologies and they're training people, right? Giving them new ideas. There's this whole flood of SpaceX employees not flood. Flood's not the right word, but there's a group of SpaceX employees who are spinning out new companies now, right? This is the benefit of what he's really built. Is he built a big company to do something really amazing and trained and taught these engineers how to build really amazing things. And now those engineers are going to go build amazing things for themselves, and they're going to create new companies. Every major company has done this, and now we're going to see it in the space. There just hasn't been anybody to like break through that, right? We've all been government contractors, working in classified missions and couldn't talk about anything. But now that's over, right? Now that's ending, and you're going to see a lot of like that's where the real next like push is going to come from, right? SpaceX has done amazing, great things, very impressive, and pushed the ball forward. But now you're going to see a different ball being kind of moved away. So they really focus on solving launch, and then getting people into space, in large bulk groups of people, mass movement of people. The people coming out of SpaceX, the employees who are spinning up their own companies. I mean, we're not even sure what they're going to do yet, and it's going to be really fascinating what they do. Right?
Yeah,
they already did this. They're going to do, think what else they can accomplish, right, when they want to.
That's it. And it's like the accessibility of this stuff now is huge, right? And I always enjoy, everything we have now has like this sort of like ice cream flavors of like 1 scoop, 2 scoop, 3 scoop pricing structure. Like, could you imagine, say 10 years ago that you'd be able to say, I'm going to create a mission control software that I can offer on the cloud in a distributed format, API accessible, and I'm going to be able to offer it at like pricing to you. It just it couldn't have been imagined that this was possible, and yet here you are.
Yeah, well, 10 years ago, who knows what I was doing 10 years ago? So that's even crazier, right? I don't even know what I was doing 10 years ago. But yeah, there's just this pull and push in the industry, right? We're pushing the industry towards cloud adoption, to using borrowing from the software industry into space to move the industry forward, move innovation forward. There's still resistance to that, right? The truth of the matter is, while we've talked a lot about commercial entities and commercial business models in space really taking off, the largest payer of space services and applications is the U.S. government, right? That's the largest payer, and so it's still driven by requirements in that very waterfall manner, and so we're pushing. That's what we're trying to do: educate, move the industry in a different direction, so that we can continue to innovate faster and not be put in these boxes that were built for 1960s technology and practices. Now we can move it forward. There's this really interesting pull. The commercial companies, when I go talk to a commercial company about using Major Tom, they get it. They understand what we're doing, and we're moving forward with them. When I go talk to the Air Force about it, I don't know, maybe they get it, maybe they don't. And so there's an education that's happening still in the industry about what, not just what we're doing, but what is a bigger picture. Microsoft and Amazon have, over the last couple of years, really put their money where their mouth is and gotten this space, and are building in space, building services in space, educating the space industry. So it's coming. The cloud is coming to the space market, which we're part of the leaders of that movement.
Now, when it comes to that sort of like ideal customer, this is a really interesting one, because you have a very unique customer set. What does the profile of somebody that not your average person goes and fills out a form for a free ebook and then you ring them up with an SDR, right?
Yeah. Well, we're not doing TikTok ads. So, we're not, there is,
not yet anyways.
Not yet anyways, right? Yeah. So our customers are, there's different ways to chop up, or categorize our customers. Our customers are very educated people who are very passionate and motivated and technical. which means they're not really interested in fluff in marketing design, and they want to know about they really want to know what's underneath in the details and the architecture of our system. And so we have to provide that. We have to be technically proficient in our software to explain it to our customers. And so that is something that is not unique to our industry, but it's part of what our industry is, right? Made of technical engineers who are running, who have a lot of say in what technologies get implemented on their missions. Past that, most of our people are not software engineers too. Most of our customers are electrical or mechanical engineers, or system engineers. They're not software engineers. So we have to make sure we're designing Major Tom in a way that it's accessible to non-software engineers, right? So we have APIs, we have some customizations you can do with our system. We have to make sure that we're building that so that it's accessible by someone who doesn't know how to code, which is great, which is just acknowledgement of who our customers are, right? It's not unusual to go to a space company and they not have a software engineer on staff. That's changing. It's becoming more prevalent in the industry that we have software engineers on staff, but it's not a guarantee, and so we have to build Major Tom in that way. From a different angle, our customers, really what we're doing right now from a mission perspective is we're really going after two buckets. The first one is new companies who are wanting to launch lots of satellites to do some sort of business application, right? Or even if it's a government program, just wants to build lots of satellites, wants to go quickly, wants to scale, wants to be able to update and manipulate and configure and integrate it into their system, right? So they don't have an architecture for their ground segment really at least established yet. So that's where we really fit in really well and start building out the architecture around Major Tom's APIs. The other segment is actually the exact opposite. It's those who are running long-term missions in space, who are wanting to lower their costs, right? It's gotten too expensive to have the server farm or whatever over here. It's gotten too expensive to maintain this 15-year-old software application that nobody else supports anymore. And so there's a whole lot of risk that it goes down or there's some sort of issue. And then obviously COVID is changing the mindset of where we need to do work, right? A lot of these older programs, you had to be in that office only. And now that is changing. And so Major Tom really can insert itself in there. And so we are lowering the cost by moving it to a cloud architecture, pay as you go type thing. They don't have to deal with the infrastructure from a hardware standpoint. We host it all. And then it gives you that flexibility of remote access to your spacecraft. And so that's another where we're going, and using the flexibility of how we design the back end, we can really insert ourselves into pre-existing infrastructure as opposed to building a new one around us. We can be flexible enough to integrate into it. So those are the two big buckets: new ventures and those who are actually the exact opposite, older ventures who are trying to more economically driven, right, or reducing the risk because they have a single point of failure.
Yes, yeah. In the world of tech, I often, we use the phrase legacy, and I always joke, if you call it legacy, I call it production. Like this is stuff that can't go away. But like you said, wrapped around a traditional architecture, littered with single points of failure. So, and they've basically built it so it can be asynchronous. We've got opportunities, and then you build the right abstraction in front of it. And this is what's neat. Now, when we talk about abstractions and cloud as an architecture, it's fantastic because now we can basically trust that you are going to do more than just fire all your services into US East 1 on AWS like most people do. Whenever people say to me like, yeah, we're using the cloud for resiliency. I said, how many regions are you using? Sorry, what? Right. Oh, no. You see, you when Route 53 goes away, the whole kit goes down. Like it's like we see these weird little things. Like, I don't understand what just happened. All of my caching just went away. All these sites went down around the world. You're like, what happened? Somebody was just like, they typed in a bad command on some software update. So you've got the ability that you can architect for scale, resiliency versus the traditional architecture people that they should be focusing on their outcomes, their business, their what they want to do with their hardware. That now they can say, hey, Tyler has a lot of customers that care about this. So if Tyler gets it wrong, a lot of people get angry versus if I get it wrong, I'm just the only one that's at fault.
Yeah. Yeah. So from our world, we have to take it one step further considering those. So we still are governed under export control. So we live in an evolving policy space. Like everything else, we're governed under the Commerce Department on export control, which is what it is. We're also under certain situations governed under the State Department, under the ITAR regulations about arms traffic. And that's a whole different level of scrutiny and consequences, to be frank with you. And so we do run in ITAR secure clouds, which does, we use Microsoft's right now that we've built on top of the Azure government cloud. We also live in the public cloud. We also can and have done air gap. Now that is a little bit of anti what I am saying. And the reason is because I described this push and pull in the industry, and I have to live in this industry. And so while I'm pushing the industry forward with cloud adoption and using best practices and moving this way, there are still missions that need Major Tom from just a pure feature standpoint, but need and have to have it in a military air gap environment. And so we do deploy in those environments. It's not something we particularly like doing. And it's not, you are losing some of the benefits of what we built, but our feature set for the satellite operators, in particular for the actual day-to-day operations, not just the infrastructure, not just the architecture, but the actual features are valuable enough on their own that they're willing to use it without the cloud infrastructure. So we run in lots of environments, for better or for worse. We do have non-U.S. customers who prefer to have their stuff not in the U.S. They don't want the data in the U.S., so we have to do EU deployments. That works better for us because the data is not actually coming in and then back out of the United States. We trigger export control. Where things live and what environments and deployments, it's a constant challenge that we have with trying to make sure that we're all on the same deployments, that we're all being upgraded at the same time, that we're all maintaining it, that is one of the challenges that we face kind of on a regular basis.
Well, I'll say it's the economies of scale are one thing, and also the economy of innovation at scale, right? So like every organization that would come to you, they would have to do this from ground up.
That's right.
And so right. You have a vested interest in becoming particularly good at doing stuff at scale versus they're just trying to solve a specific problem and then having to build architecturally around the infrastructure to support that problem. It's such a you are truly this sort of the cloud computing of mission control, because you can say, like, you don't need to care about where it is. Obviously we do, and you have to be transparent about that. Yeah. But they don't have to run it. They don't have to have this network operations center with 25 TVs and people up 24/7 watching screens and listening to bleeps and boops and wondering what's going wrong.
Yeah, that's right. And some of our customers still choose to have those 25 TVs and everything going on. They like it, but they also want the benefit of what we're bringing. So yeah, that really moves into, we've talked about the kind of the architecture into the actual, like, the application itself. We rely heavily on automating a lot of these processes so that we don't have to have person sitting at a monitor 24/7, because satellites don't sleep, right? They don't take holidays. They're always constantly collecting and transmitting data down to Earth, and there has to be a system in place to collect that, right? And so Major Tom can fly. He can be your autopilot, right? For these satellites, where you used to have teams, 24/7 operations. We can now reduce that human intervention that costs from both from the employee standpoint, but from the individuals. Nobody wants to be up at 2 a.m. flying a satellite, right? That's not a sustainable model. So that's really where we're moving into the application side, giving these tools and automation, both from internally the Major Tom, but also giving you the APIs to automate your own workflows for operations. And so I think that's really another angle that we're coming at this problem at.
It's funny that because you've been very focused on this is where you run, right? This is where you operate. There's no edge in any of the nomenclature around what you're doing, because you are truly sort of the cloud. Like mission control is the cloud for the edge payloads, the actual workloads that are physically swimming around in orbit. But it's funny that everybody is kind of like, I call it the edgification. Like it's really just everybody's taking anything to do, and like these glasses, they're edge glasses now. Like everybody is just like latching onto it. First of all, thank you for not just jamming edge all over your website to like try and be exciting to the edge world, not to detract from them. All of my amazing friends who are into the edge, but
of course.
Where do you see that sort of next layer of compute coming, and is it something that you're interested in as a company?
Yeah, so we have thoughts around this and trying to understand what our role is in this wave that's happening, right? I think one way that we're looking at it is as we continue to develop Major Tom and we continue to build out new capabilities, being able to optimize this network, right, for communication that we've talked about. What at a higher level, I think one thing we're trying to do, which I don't know if this completely answers your question, but fine, is erase the differences between space and ground, right? That it's all just one network. It doesn't matter if you're satellite or if you have a server down here or you have an IoT node in the Sahara. It's all just a network. And erasing that there has to be some sort of division, right, from a network perspective. And so we're trying to move the reliability and the communication of space to where we have on the ground, so that we can run edge processes anywhere, whether it's on the earth or on the ground, be able to shift these things around, manage this from this perspective. There's also a lot of push right now for satellites to become smarter, right? That they're not just simple machines, effectively, right? Really complicated, simple machines, right? We want it to be intelligent. We want them to make decisions on their own and not be dictated from the ground, right? That's a movement that's happening. So getting the compute power on the spacecraft to allow it to do the computation, apply the AI or machine learning in real time at the data source, and then be able to make decisions and execute from that without ground interference. So there's really two trains of thoughts on that. We've looked at, because of our experience in flight software, we know how to go play in the satellite world, right? We know how to go put stuff on orbit, and there's an element of that long term that has potential there. If you control the satellite software and the ground software, it's a really powerful ecosystem that we're building. And so using containers, we can really push, at least the security profile, at least the new application on the spacecraft, and allow Major Tom to manage that system. So we're looking at where we fit into this whole thing. It's still new. We have different restraints with compute power on orbit with just actual energy, right? And so these are on constant fighting, and then it's the heat that they create and getting distributed. So there's a lot more complications. So it's not as fast evolving as it is on Earth, but it is there. You're definitely going to see space companies with edge computing all over their websites. We're not one of them, but there are those companies, and so we're working with our customers, understanding their needs, what they're doing, so that we can be a part of their ecosystem moving forward.
Well, the irony is that you effectively were like, you're like edge hipsters. You were there before it was cool. Like Kubos,
Yeah,
in effect, is the edge
sure.
OS, right? Like you could
That's right.
almost say your tagline could be, "We've been to the edge and back," right? It's like, because you realized the problem that you could have the most impact in solving was that mission control, right? Like this is where, like, you've understood the other side. You understood the payload. You understood the edge requirement, and that allows you to be so focused and, very pragmatic and fanatical on solving this problem with Major Tom, so that down the road, when someone says, "Hey, we want to take this a little bit further and we want to move it to another location," you do air gap. You do all these things. You've had to think that stuff out and execute on it. It's pretty amazing that the company could go in interesting places, for sure.
Yeah, we have the technology and the experience to go in a lot of different ways. Right now in the short term, we're all steam ahead on Major Tom, right? Building this product to really manage the ground infrastructure for your spacecraft operations. And so this is where we are. Where we go in the future, we have a lot of different visions that we want to see come to reality. And it's pretty exciting that what we can do. Software is really going to give new life to these missions, to this hardware. Once you launch the hardware, that's what it is. Well, software, we can constantly, when we build that infrastructure and do it in a safe way, we can give new life and new missions to old hardware. And I think that's going to change things. There's a case to be made that they're just new server farms in space, right? Amazon's just going to move all their AWS
the ultimate
to space,
outpost,
right? That's right. And you don't care if it's on Earth or it's in space, as long as we can increase that communication to make the latency go away. But anyway, there's complicated problems, big problems to stall here, and where Major Tom fits in the future. We're focused on communication bandwidth optimization. That's always going to be a huge problem with FCC frequency allocations moving forward. People experimenting with laser communications. This satellite to satellite communication is now a thing that's happening, and so I personally believe that the communication bottleneck that's going to be happening here, that we're already feeling the squeeze of, is a major place that we want to plant our flag, that we're part of this solution. We're part of the optimizing and really the communication channels of this network.
Most people would just even think about that and they would get out of the business. You've chosen some hard problems to solve, and I wouldn't say hard or difficult or challenging, but like making it commercially viable. This is a pretty incredible thing that you and the team have taken on. What made you think, this is a problem I need to solve, and I think we can do it?
So Kubos is how we got in the industry. My partner really had the idea for the flight software because he built satellites, and he was trying to integrate these different subsystems that were built by different manufacturers to talk to each other, and they weren't standardized across any sort of platform and so he had to build it all from scratch, right? And there's a better way. We could build a better system that already is integrated with these systems, or make it easier to integrate these systems. So that's where Kubos came from. When we spent time in the industry, understanding the customers and our partners in this industry, we realized there was a huge need for how they were doing operations. There was a need for the scalability, for new practices, new architectures, new development speeds that we weren't seeing. And so we saw an opportunity to build Major Tom. We had the networks, we had the relationships to present this product quickly to people, and so we did, and we've had success doing that so far. And so that I didn't come from the space industry, and so I had to really dive in and learn it kind of from an outsider's perspective. And operations. So look at it this way. So you have three major phases of a spacecraft life, right? You have the development phase where you're building it, designing it, building the spacecraft, testing the spacecraft. Then you have launch, right? That's a big moment of itself. And then you have operations. Out of the three, the longest time period is operations, right? But which one's more costly? What's the most expensive bucket? And so it used to be development and launch were the most expensive bucket. So the industry created CubeSats. They created also Moore's Law, created cheaper components and faster components. So we lowered the cost of development significantly. Obviously, SpaceX has come in and focused on launch problem and lower that. But other companies like Rocket Lab have come in and done this to lower the cost of launch and the reliability and the speed of launch cadences. But no one's touched operations. Operations is still this long-term, expensive bucket. And now it's disproportionately more time and money than the other two buckets. So that's really where we're trying to solve. We do have tools for development and testing, but we're really looking at lowering that so that if we lower all the costs of the entire life cycle of the spacecraft, then we will make space more accessible. And while that's kind of a token thing right now that people want to democratize space, it's kind of almost becoming cliche to say, the truth is if we can get the price down, right, this is going to increase development. If we use skill sets that already exist in the world, like software engineering is a huge skill set that has changed our world completely, and if we apply it to space, if we give them more accessibility to these skill sets, see what else we can do. There are more software engineers entering space, more software engineers building software or building software companies in space. So it's this great. Anyway, that's what
it's a beautiful, empowering loop, right? And
yeah,
if you don't mind, I mean, we got a few minutes left. I want to touch on TechMill and the ecosystem and your participation, because like you said, you weren't born in the space, race, but you're in it now as an entrepreneur.
Yeah.
What are the ways that you see excitement in that startup community and where we can give back?
Yeah, so TechMill TechMill started before Kubos. It was a nonprofit in the town in Texas where I was living. It was a bunch of technology and entrepreneur enthusiasts got together and decided we need to create some sort of organization, nonprofit, to help other entrepreneurs, give at least a community feel to it. So we did events. It was actually the first co-working in our town. It started in a coffee shop and we moved into an actual co-working space, and it spun off and done its own thing. That's actually where I met my partner who started Kubos with. He was the president of that organization. I was the treasurer, and we started working. That's how we met. That's how we started working together. Obviously, wow. Kubos was born out of TechMill to some degree. And so it's a nonprofit that's still existing. They do a lot more like developer evangelists, education, community, building a community of people who are interested in tech, who are interested in startups. When Kubos was taking off, when gaining traction, I stepped down from the board of TechMill so I could focus on Kubos. And I'm now no longer in Texas. I've actually moved to Portland, Oregon at this point. So TechMill's still doing great, but I don't have any involvement in it, and haven't in a couple of years.
But it is amazing if you think of communities of purpose, and there are so many out there. It is a beautiful thing. Like ultimately, you are exactly the success path that any community of purpose should have, is that you shouldn't be running it for 30 years like a lifelong member. If you can contribute and be a part of it, it's one thing, but you ultimately create something, you sort of parachute out of it into a new thing and prove that the value was there. And then somebody else says, hey, check it out. Tyler used to be he was our guy. And now that gives them something to aspire for, right?
Yeah, I mean, Tedmill was a really interesting point in my life. I was coming out of another company that I just shut down. It wasn't technology driven. It was a service based company, and I was looking to get into tech. And it wasn't space per se. I was looking to get into tech, and I needed new networks and I needed new people to meet than what I had been exposed to. And so, Tedmill, I went to just a community event being put on about people just wanting to share big ideas, right? What are big? It doesn't matter the context. And I went there and they talked about creating this conference for technology people, for software engineers, and they were looking for volunteers to help run a conference. And I volunteered. And so I think that's a really great line in my life, is that I'm not afraid to do things I don't know how to do. I didn't know how to run a conference, but I jumped in anyway. That led me to starting a nonprofit, which I didn't know how to run. And it led me to meet Marshall, to build a space company that I didn't know anything about space. And so it's just a continuation, but you're right. So Tedmill has thrived and has done a lot of great things and supported a lot of different startups, a company, Kubos being one of them. So we have a special place in our heart for Tedmill, but that is really what it's supposed to do. Supposed to incubate a little bit, give you some resources and connections, and then kick you out. Go build. That's right. So that's what we did. I did it with myself, and so that has worked out so far.
Yeah, this is and those things are out there. And I think for folks that are listening too, it's just a reminder that like there are great communities of purpose like that you can go out, and whether it's whatever it is, they're out there, and it's very, very helpful, at least just to find people of the birds of a feather sort of opportunity. Sure. And it gives you a chance to share your ideas, to vet them out with people. And if nothing, you just meet amazing people. Right? Obviously the in-person thing has, the lack of in-person opportunity has drastically changed how we develop and nurture these communities, because it's a lot harder. Like, we're tired of staring at bloody Zoom screens and everything all day long. So the last thing you want to do is like, hey, I spent all day on Zoom meetings. I'm going to go to a 3-hour evening Zoom session with people. You're like, I hope that we get to the other side of this all soon and we can get back to those things, and you'll see a lot of interesting stuff come out. Yeah,
I completely agree with you. It's been a challenge, but yeah.
So I guess for folks that want to find out more and want to get connected to you, Tyler, obviously we'll have links to, first of all, there's so much that's going on. And I didn't even talk about like the super launch sequence you've had. August was a huge month for you. You've got customers that are doing incredible stuff. I feel bad that I didn't open with that, because I was excited on your behalf for all of the stuff that you were involved in. And that's really cool. But for folks that want to get connected, what's the best way to do that?
Yeah, I mean, our website is www.kubos.com. So that's a great place. We also have a podcast there that you can listen to. We're interviewing other our customers or our employees, and giving you an insight into kind of pushing the cloud adoption in our industry. That's great. I'm on Twitter, if that's a thing, but I don't talk a lot. So, but I'm there. Our website's the best place to get a hold of us.
And students as well, right? There's a great opportunity. You've got the academic access pass. There's different ways that people can get involved, which is pretty cool. So
that's exactly right.
Thank you for doing all that you do.
Yeah, no, I appreciate it. Thanks for having me, giving me the opportunity to speak to your audience and share my story and what Kubos is doing. I think we're really in an interesting place right now.
Onward and upward. It's going to be, I'm excited to see the future. We've got a lot of good stuff ahead. Thanks very much, Tyler.
Yeah. Thank you, Eric.